Hello everyone, my name is Soumyaranjan Das, and in this video I am going to be discussing on how to solve a problem on the topic minimization of DFA. So in the minimization of DFA we use the table filling algorithm. In this algorithm the first step is we'll remove all the non-reachable state from the start state. The non-reachable state will be those states which have an outgoing edge, but there are no incoming edge, so they are not reachable. And so the next step would be to check the pairs. For example, if there are q0 q1 or two pairs, just for a single pair, just for an example, if one of them is a final state and the other is a non-final state, then we'll accept the pair and put a cross mark against it. If there are two pairs, if in the pair both the states are final state, then we'll not accept it. As well as if both the states in the are not the final state, then again we'll not accept it. If one of them is a final and the other is a non-final state, then we'll definitely accept it. And so we'll use it for all the different instances of the pairs. And so we'll do this until no more markings can be made. Then we'll combine all the unmarked states and that will form our DFA, minimized DFA. For a minimization of DFA problem, we'll use the table filling algorithm. So in this question, we have four states Q0, Q1, Q2, Q3. Q1 and Q2 are our final states and they are represented by double rings around them. So we have created a transition table where Q0 upon attaining A goes to Q1, Q0 upon attaining B has a self loop and it comes to Q0 itself. Q1 on attaining A goes to Q2 and Q1 on attaining B goes to Q1 upon having a self loop. Q2 or upon A goes to Q1 and Q2 on B goes to Q2, again a self loop. Q3 on A goes to Q1 and Q3 on B goes to Q2. So here, according to the first step, we look at the states which have no incoming edges, only outgoing edges. So those type of states are called non-reachable states. Here Q0 has an incoming and outgoing edge, Q1 has an incoming and outgoing edge, Q2 has an incoming and outgoing edge. However, Q3 has no incoming edge, there are only two outgoing edges. So we have decided to remove Q3. In our next step, we remove the Q3 and we create the DFA again. So we have Q0 upon A, it goes to Q1, which is our final state. Q0 upon on B has a self loop and it comes to Q0 itself. Q1 on attaining B goes to Q1. Then Q2, which is our final state, Q2 upon attaining B goes to Q2 itself with a self loop. Q2 on A goes to Q1, which is again a final state. And so this is our DFA after removing Q3. Now we will create this table with Q1, Q2 as our rows and Q0, Q1 as our columns. And we'll check them as a pair and see there should be one final and one non-final state. If that's so, then it satisfies our condition and we'll put a cross. So Q0 and Q1. Q0 is our non-final state and Q1 is our final state. So we put a cross over here. Q0 and Q2. Again, Q0 is our non-final state and Q2 is our final state. So we put a cross over there also. Q1 and Q2. Q1 and Q2 are both our final state and it isn't eligible for us to put a cross. So we leave it empty. Now we create a transition. Here we take it as a pair Q1 and Q2 on attaining A and on attaining B. Q1 and Q2 on attaining A. Q1 on attaining A comes to Q1. Q2 on attaining A comes to Q2. Q1 on attaining B comes to Q1 and Q2 on attaining B goes to Q2. So what we understand over here is, upon attaining A and B, they will go to their self loop, and these are the non-marked states. So now we create a DFA accordingly, Q0, Q1 and Q2, because Q3 was a non-reachable state, and so we had removed it. Q1 and Q2 are taken as common because this pair is not marked. So Q1 and Q2 are common, and Q0 is the different state, or shall I say distinguishable state. Q1 and Q2 are the non-distinguishable states. So Q0 on attaining A goes to Q1, and Q0 on attaining B comes to Q0 itself. So we have shown it as a self loop. Q1 and Q2. Q1 on attaining A goes to Q2, Q1 on attaining B goes to Q1, and Q2 on attaining A goes to Q1, and Q2 on attaining B goes to Q2. So we have marked it as a self loop. On attaining A, they come to Q2, Q1, so it's a self loop, and on attaining B, it goes to Q1 and Q2, so it's again a self loop. And so this is our simplified DFA. So moving on, we are now going to be discussing about indistinguishable and distinguishable states. So distinguishable state in this problem would be Q0, and indistinguishable state will be Q1 and Q2. Q1 and Q2 will be the indistinguishable state because upon transitioning they show similar features, so we can't really distinguish between them. And on distinguishable state Q0, because Q0 shows different features than both Q1 and Q2 on going to transition from A and B. We have now come to the end of the video. I would like to thank you for watching this video.